Hello everyone, welcome to today's video. So this is day 2 of the crash course and today we'll look at quadratic equations. So for the problem solving sessions, all of this will be done inside the app when you take the crash course which will be launched in a few days, like 2 to 3 days maximum, and we will launch it section wise. It would be very affordable and it would be less than almost 1000 rupees. So it should be around 600 or 700 rupees only, but the content that you're going to get it would be completely of JEE Main and Advanced Standard, and there would be a large number of videos, test series, assignments, and everything else provided. This is to provide you with a complete set of materials so that you do not need to look elsewhere. And also, our app is launched, so you can see the app on the screen. So you can download it from the link in the description. I will also provide a detailed video on everything separately for this, but for now, you can download and access the free test series that has been provided for complex numbers. So after this video, we'll also provide a test series of quadratic equations as well. So let's begin with the theory portion. So this is basically the theory crash course. Once we are done with that, we will try and do problem solving sessions both on YouTube and also on the app. And inside the paid courses, basically, you will get live sessions, doubt clearing sessions as well with live problem solving sessions, along with all the required theory material, test series materials, and everything else. Okay. Okay, let's begin. So, quadratic equations, you have already studied this in class 10. So what it says is that if you have x squared plus bx plus c equals to 0, right? Where a, b, c are real numbers. Now, this is a quadratic equation. Now, the solution to this quadratic equation is simply given by x equals to minus b plus minus root over of b square minus 4ac whole divided by 2a. This is the Sridhar Acharya's formula. Now, this is what we know. Now, as you can see, there are two values that x can take as per the equation. These two values are respectively called alpha and beta. You can call them something else if you want, but these are the roots or zeros of the equation. And this is called a second order polynomial because the highest degree is 2. So say it's a second degree polynomial, correct? Now, this alpha and beta, they are related with the coefficients of this equation in a certain way, and those are called Vieta's relations. So we will first look at what is Vieta's relations for a quadratic polynomial, and then we'll also look at for a general polynomial like cubic, quartic, or any nth degree polynomial as well. Okay. So first of all, there are two relations you should always keep in mind. The sum of the roots, which is alpha plus beta, is minus b upon a, where b is the coefficient of x. Remember, it is not the coefficient of minus x or anything else. It's the coefficient simply of x. So whenever you're given a quadratic equation, try to rearrange it, everything to the left-hand side, and keep the right-hand side at 0, and then use that. And the second equation is alpha into beta is c by a. Okay. We can use these things to solve problems. So for example, we will take a small example here. Let's say you have the problem 2x squared plus 3 minus 5x equals to 0. So this is not exactly arranged like this, but you can identify the coefficients from this. So that is your first task. A is 2, as you can see. So this is your 2. B is the coefficient of x, which is minus 5, right? See, it's minus 5 and not 5. So I am careful about that, and it's not 3 as well. It's the coefficient of x. And C is the constant term, which is 3. And once you get that, you can write alpha plus beta is minus b by a, which is 5 by 2, and alpha into beta should be c by a, which is 3 by 2. And you are done with the roots. And the questions we usually would be concerning about the roots, alpha plus beta, and some relationship among alpha and alpha plus beta. So, some relationships which you can easily find using this Vieta's relations are as follows. So, alpha square plus beta square, this can be found easily as alpha plus beta whole square minus 2 alpha beta. And you know the value of both of these things. Alpha cube plus beta cube can be easily found because this is again alpha plus beta whole into alpha square plus beta square minus alpha beta. And you can again express this like this. Alpha square plus beta square, you already know. If you are given reciprocals, you can again find them easily because 1 by alpha plus 1 by beta is alpha plus beta by alpha beta and so on. So I hope this is clear how to find any value of regarding alpha and beta, the symmetric polynomials, in terms of whatever we get from the Vieta's relationships. Now, after this, We also have a type of question where we are asked to find a new equation. So finding new equation from given roots. Okay. So how do we do this? Now, let's talk about an example. So again, let's say we have the polynomial x square minus 2x plus 5 equals to 0. And this polynomial has roots alpha and has the root beta, correct? Now, question is find a new polynomial with roots. Let's say the roots are, I will keep it simple here. Let's say alpha square and beta square, correct? Now, whenever you're asked to find a new polynomial with certain roots, first define the sum of the roots. So, what's the sum of the roots of the new polynomial? That should be alpha square plus beta square. Now, what is this value? Can you find out this value using the value you already provided? Since alpha and beta are roots of this equation, what is already true? Let's write down what is already true from Vieta's relations. It's alpha plus beta is equals to 2, correct? And alpha beta is equals to 5. This is already true. So then the sum of the roots alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta, correct? And this would mean that this is basically equals to 4 minus 10, which is minus 6. And similarly, the product of the roots alpha square beta square is nothing but alpha beta whole square, which is 25. Now you got both the things. Now remember, in the new equation, you simply write it like this. The new equation would be x square minus sx plus p equals to 0, where your s and p are given as follows. So your new equation should be x square minus 6x, actually plus 6x because s is minus 6 plus 25 equals to 0. So this would be the new equation which has the roots alpha square and beta square. I hope I'm clear on this part. Now, there's not much theory to be done in quadratic equations. Let's look at Vieta's relations for a cubic polynomial, from which we can understand how it can generalize to any polynomial. So Vieta's relation would simply say that, let's say you have something like this: ax cubed plus bx square plus cx plus d. Now, this equation has roots alpha, beta, and gamma. What we can say is then, in a similar fashion, alpha plus beta plus gamma should be equals to. So it's a third degree polynomial. So begin from the term of x, which is one less than the highest power. So basically from x square, what is the coefficient of x square? B. Again, it should be minus b by a. Now, this is sum of the roots. Now, take two at a time, take two roots at a time, and then sum them. So alpha beta plus beta gamma plus gamma alpha. Right? This should be then now. Now again, alternate the signs. It was minus, so now it should be plus c by a. So you basically keep going in a descending order of powers of x and take their coefficients, divide it by the coefficient of the leading term, and alternate between the signs. And on the left hand side, you simply keep increasing the number of roots you take every time. Now, three at a time: alpha, beta, gamma. This should be minus d by a. And this process can be followed for any degree polynomial here. Any degree, it could be an nth degree polynomial, a 10th degree polynomial, anything. Vieta's relations would remain the same. And the last thing I would like to say here is transformation. Transformation of equations. Transformation of equations. And in the transformation of equations, we basically can do this. Say we have an equation like this, where let's say ax square plus bx plus c equals to 0 is given, and you are given it has roots alpha and beta, correct? And let's say you are asked to find something like this. You are asked, what is the value of f of alpha plus f of beta, where f is a function? What do you do? So you can either calculate the value of f of alpha plus f of beta based on the Vieta's relations, which is alpha plus beta and alpha beta, or you can do one thing. You can simply substitute y is equals to f of x here. And if you substitute y equals to f of x into this equation, and then make it into a new equation, a new quadratic equation in y, which might look something like this: py square plus qy plus r equals to 0. Using this substitution, what happens is this new quadratic equation will have roots f of alpha and f of beta simply. And which means that f of alpha plus f of beta would simply be minus q by p in this equation according to Vieta's relations. So you simply need to try and substitute the value y equals to f of x into this equation, or basically you have to find out x equals to f inverse of y, where if f is an invertible function, only then it would work, correct? So we will talk about all of this in the problem solving sessions as well. But this is all the theory you will need for JEE mains. So best of luck for the attempt. And also, if there's any doubt, please let me know here. And also, please download the app. You can talk to me there inside the app and other members as well. So hope to see you inside the app as well. And also, if there's anything else, do comment below. If you're new to the channel, do subscribe. Thank you.